So as you read through this one here, we want to figure out how long ago the mammoth died. We're dealing with carbon-14. Remember on the beginning of the notes for this section, I had said that the K value for carbon-14 was this. So we need to refer to that, even though it's not given to us in the problem. So whenever you're dealing with half-lives in carbon-14, this is your value of K. In my opinion, since we're dealing with carbon-14, we're dealing with the scientific. We're also dealing with decay. The amount of carbon in the bone gets smaller with time because we want to know how much has gone by for only 3% to be left. So we start out with our scientific exponential decay. We're looking for how long, so that means we're looking for what the time is. So we're going to put time here. We're going to put in our value of K. Now, A has to be your initial amount. Y is the amount left after so much time. Well, we're not told the particular amount, but we did start out with 100%. And 100% as a decimal is just 1, equal to what we have left, which is 3%. So we take 3% as a decimal, we get 0.03. Now, multiplying by 1 doesn't change it, so that 1 really disappears. Now we would have the part with the exponent by itself, so we can use logs to get rid of it. Dealing with the natural number e, let's take the natural log of both sides. Natural log of the left side and natural log of the right side cancels out e, leaving you only with that exponent. So now to get t totally by itself, we have to divide by what t is being multiplied by. This is your calculator ready form. Then we're going to go ahead and type that into your calculator and we'll get this. Notice the units here is years. Taking a look at this one here, we have a population of city that's increasing at 3% a year. If the population continues at this rate, how long will it take it to double? Well, in my mind, I'm not seeing any chemical elements or anything like that hanging around, so I'm not thinking scientific. So we're going to use the non-scientific ones that have R in them. We're also looking at this getting bigger because it's increasing, so it's an exponential growth. So we're going to use our exponential non-scientific growth one. So we have 1 plus your rate. Well, our rate is 3%, so we're going to put in 0.03. We're looking for how long. Well, how long would be our exponent of t. And then a is what you're starting out with. Y is what you're ending up with. It says we're starting out with 1,000,000 equals, and we're looking at for it to double. So if you start out with 1,000,000, that means we need to then end up with 2,000,000. We're now going to go ahead and solve this. We could go ahead and type this in or do this part in our head, and we get 0.97. We'd have no, not 0.97, I did that wrong, 1.03. So we'd have 1.03 raised to the t, but we cannot multiply 1.03 times 1,000,000 because the million does not have the exponent of t by it. So we'd have to get rid of that million, so we'd have to divide both sides by 1,000,000, so we get 2 is equal to 1.03. Now that we have the part with the exponent by itself, we can use logs. Whether you would use common logs or natural logs doesn't make a difference, but we just use one of them. In this case, I used a common log because I'm not putting any base on it. So now, exponent after log, put that exponent down in front. We now have our variable of t multiplied by something. To undo multiplying by log of 1.03, all I have to do is divide by it. So then I have log of 2 over log of 1.03, which is calculator ready form. Then we just have to go ahead and type that into our calculator, and we get about 23.45 years.